In this scene, we're going to set up these fantastic gloopy mixing liquids by using FluidFX. We'll set up particles with different fluid densities, which means they'll mix in this interesting way, and then we'll mesh one of those for a more refined look. So let's jump into Cinema 4D and get started. So here we are back in our 6 splash scene file. So what we need to do is move on and do the final part of this section of the entire animation, which is filling up the number 5 with our gloopy liquids. So what we need to do is borrow an element. We need the mode text again, of course. Let's hit Control-C on our mode text object. We'll go to File, New. Let's paste in that. We can make it visible again. There's our number 6. We need this to be a number 5, so let's go to the text box and put a number 5 in there. There we go. And now this is ready to be the kind of container where we can fill up our gloopy mixing liquids. Right, before we move on, let's get saved up and organized. So we'll hit File, Save As, and let's just go to our parent MoGraph folder. So we'll make a new folder first, because remember we're doing a folder per scene here. So we'll go XP, and we're going to call it Countdown, and it's another 5, but this time it's going to be 5. I missed a T there on my count. Let's get this correct. Countdown 5, and let's call this 5 fill, because we're filling it with mixed liquids. So I'll just copy that before I hit enter. Good. Let's go in there. We'll call the file name that, but let's give it this version 01 suffix so we can save incrementally. Very nice. Let's go back into our file explorer and go to my library MoGraph menu, and inside our new folder of 5 fill, where we have our scene file, let's make a cache folder as well. So that's all ready to go when we need it. Great. All right, we're ready to go now. So what do we need to do? Let's give this a display tag again, because we're going to be filling the internals of this 5 with liquid. So let's go to Tags, Cinema 4D Tags and Display. And we will hit Use, and we'll use lines instead of shading, and we will click isopalms so we can really see inside that easily. And of course we're going to need an xParticles collider tag, because we want particles to be trapped within this volume. So let's go to Tags, xParticles Tags, Collider. We want it to be colliding on the inside of the volume, so normal's inside. Let's take away the bounce. Right, so there we go. So we're ready to start with our xParticles system here. So let's bring in an xParticles system. Let's just deactivate the icon and viewport. All right, so what we want to do is we are going to have this fill up with liquids, but instead of the method we used for the number 6 fill, where it just one emitter gradually filled this up from the bottom, we want lots of kind of splatty, gloopy explosions going off within the volume of this. So let's start off by just doing one emitter, and then we will build it from that one emitter. So let's go to, in fact, let's just drag that mode text into the other objects. Let's stay organized. And we will go and let's get this emitter. Change it in the object tab from the default square emitter, this rectangular shape, to a sphere. And then we can put this sphere way down, maybe 4 centimeters or 5 centimeters. And now that is within the volume of the 5. So if we hit play, you can see that the behavior is happening that we want. We have this emitter spitting out particles inside the 5. Now remember, look, the particles don't seem like they're touching the edges. That's because they have a radius, and we're just looking at the dots here, the central point. So let's go to the emission, and let's put that radius down to, say, 1.5. Okay. Now, we don't want these to emit in rate. We want them to be in shot mode. So we're getting this blast of particles like that. Okay, so you kind of get the idea here. We're going to have several of these emitters blasting out, which will then become like gloopy liquid. Okay, very good. So What I'm going to do now is I'm going to take away, let's get all of this speed and remove it and see what happens. Okay, so we've got a lot of particles which are completely static, and that's because they have no speed and there are no forces moving them around in this scene. So that's our starting point. Let's reduce our shot count down to about 700. Which may not sound like very many for a fluid sim, but remember, we're going to have multiple emitters in here, perhaps even 15 emitters. So this number is going to be multiplied by, 10, 15. Right. So let's turn this into a fluid simulation now and actually get the real physics working. So we're not actually going to use a gravity in this one like we did in the 6 fill, because we don't want these liquids to be pulled downwards. We want them just to interact with each other, which is going to give us that really nice wobbliness. So let's go to dynamics, and we will go to the dynamics objects pull down, and let's bring in a fluid effects. And now when I do this, something is going to happen. So remember, these particles have no speed whatsoever. Look what happens when we activate our fluid effects. There's a big blast of energy. So what's happening? Well, this is because fluid effects does a couple of calculations, well, it does lots of calculations, but what it's doing is it's analysing particles and it's giving them a fluid density value. And the basics for this are, if you have few particles which are very spaced apart, then the fluid density is going to be very low. If you have loads and loads of particles that are very close together, the fluid density is going to be very high. And if the fluid density is very high, it's going to create a high pressure, which is blasting them apart. So this is why we have brought in some special emission modes in the emitter. It is to ensure that we don't birth particles in a way where they have lots of particles very, very close together. So if we go to the emitter settings, let's change the display to circles. We'll put ambient occlusion on. If we switch off the fluid effects and just spawn the particles, you can see we've got lots and lots and lots of particles spawned very, very close to each other, on top of each other, filling this spherical volume. And because they're born in that state, they're given a very, very high fluid density amount, which creates this high pressure, which blasts them apart. So the two emission modes that we have got to prevent this from use in fluid sims are, let's go into the emitter tab, are hexagonal and regular. And what these do is they take over the particle count, and they base this on the particle radius. And what they do is they spawn particles in, let's just put this so it emits on one frame. They spawn particles so that none of the particles are born in an intersected state, and they perfectly fill up the volume of our emitter. So we have no extra particles. So there's two things happening. They aren't born as closely together, and there are far fewer particles because we have it in this mode. You can see we've got a tiny amount. In the previous example, we had 700. Here we have possibly 30 particles. And as a result, these particles won't be given a very, very high fluid density amount by the fluid effects. And in this state, you're not going to get that explosive blast. So let's just press play and see. And there we go. We get no blast at all. We're just playing it. But because they don't have this very high density state when they are born, we don't have that explosive blast. And then regular is very similar to hexagonal, but instead of it being an hexagonal grid within the volume of this emitter sphere, it is a regular grid. And so for almost the majority of fluid sims that you'll be using with xpFluidFX, you'll want to have your emitters in this mode because you don't want particles born in a high density state, and you don't want fluids to kind of have this explosive blast on the first frame. You want them to be born and then to drop downwards with the gravity and behave like fluid. However, we are actually going to harness that element of fluid effect solving to our advantage. So we're going to put this back down to shot. And we want this initial explosiveness because it's going to work really well for us to be the kind of the start energy to get this gloopy, wobbly mix of fluids. So let's go back to our emitter. And we can put this display, let's put it back down to dots, because we're going to be getting lots more particles soon, and we're not going to want the overhead of having to draw all of those circles. All right. So what we're able to do, let's go to our FluidFX settings. Now what we are going to do is keep the accuracy on the fast preset. Now on the fast preset, it means that all of these parts of the FluidFX solve are done for you. And the parts are how many sub-steps the solver uses and how many iterations it uses. And now it uses sub-steps to accurately solve for velocity of the fluid particles, and it uses iterations per sub-step to solve for accurate fluid density of those fluid particles. And when you're more experienced with fluids, you are able to set this accuracy to custom, and you're able to set these values yourself. But for us, for this scene, it's a very, very simple FluidFX scene, and we're going to keep the accuracy on fast, which means it'll solve really, really quickly, but the fluid simulation wouldn't be as accurate if we upped these settings. But we don't need that for our purposes. It'll work on fast. There are a few settings we are able to change even on fast accuracy, and we're going to use some of those now. Now, by default, we have an internal pressure and an external pressure amount. And what this does, the internal pressure tries to prevent those particles from compressing. And because fluids shouldn't compress. And so we have this internal pressure to stop them from compressing. But if that were the case and there was nothing kind of holding them together, they wouldn't form those nice water globules. So then there is also an external pressure to encourage them to stay together. And this is a little bit like creating a surface tension, like really nice water globules. And when you're solving for perfectly accurate fluid sims, these default settings of internal pressure of 100 and external pressure of 30 are very, very good. In most circumstances, they're going to be perfect for you. However, we aren't doing a realistic sim. We've got no gravity in the scene for a start, so we can actually reduce some of these. So if I reduce this internal pressure, you will see immediately that this initial explosion isn't going to be quite as wild. Let's put this internal pressure way down to, say, 30. You see how it's far less explosive without that internal pressure. And also, the external pressure we're not particularly concerned about, because our particles are going to be confined within this space where there's no place for them to leak, and they're going to be bulging against other particles. So we're not concerned about them forming kind of globules of water droplets. We don't need that. So let's just take away that external pressure. And the only other thing we have open to us here is we can increase the damping, which will further kind of draw some of the energy out of this and will make it less explosive. So we put the damping way up. It's just slowing it down somewhat and taking some of that energy out. We'll put that damping up to, say, 50. Okay. So we've got this nice blast of initial particles, which is working nicely. And you can already see, even with one emitter, we're getting some kind of swirling going on here. So that's looking pretty nice. Okay, so let's just start organising our scene a little bit here. What we could do is, before we start duplicating emitters, we could name them correctly and then get that set up before we start duplicating and making copies. So let's go to the emitter, and this one we'll change the name and we'll call it emitter blue. Let's make these the blue ones. Let's go to the display tab and we'll get our particle color and change it to a nice blue. Let's make the icon color the same to stay organized. And there we go. So let's just start making, I tell you what, we're going to have lots of particle emitters here, some of which will be blue, some of which will be another colour, which will be our other fluid. So let's get organised immediately. We'll go to the emitters tab and we're going to create a subfolder. So let's call this one blue emitters and create subfolder, which creates a folder in our hierarchy, and we'll drag that in. Okay, and now we'll just hit Control, and we're going to make some copies of this emitter. So let's put one here, 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 and another one there. All right, so now we're going to start seeing the start of the effect that we're after much more clearly. Let's have a look. So that you can see the initial explosion and then this nice swirling motion that is happening because of the fluid solver. That's looking good. Let's actually, we haven't got that many particles yet still in our scene. So let's change this from dots to circles filled, which will give us a better understanding. There we go. All right. That's looking really nice. Now, what we're able to do is we can further change. We've changed some of the settings within our FluidFX solver here, but also remember we have some fluid settings in the emitter itself. So let's do that. And we're going to do very similar settings that we used in the 6-fill scene. Let's go to Extended Data, Fluid Data. And what we want to do is, remember, we want to exaggerate these lovely, nice kind of swirling curls. So to do that, let's reduce the viscosity. Let's increase the vorticity large and small, which, you know, will exaggerate this swirling motion. And let's reduce some of that surface tension. So in fact, those are the same settings that we used in the 6-fill for a similar effect. Okay. So now what would be nice with this would be if instead of all of these emitters emitting on exactly the same frame, they were staggered. So there's a really nice Cinema 4D kind of shortcut almost for getting this set up. Let's just highlight them all, go to the emission tab, and what we want to do is we want to kind of stagger this shot time. So if I just type in num here with all of these selected, look what happens. Press enter and it changes to multiple values. And if I go into each one individually, you will see that the first one is set to emit on shot 0, the second on frame 1, third 2, and so on. So that's really handy, but we can do more with this. Let's say we want the gap between emissions to be more than just one frame. Well, all we have to do is just highlight them all again. And this time if we put num and times, say 4, it's going to give a 4-frame gap between those emission times. So let's have a look. Hit that, multiple values. So the first one's on frame 0, second one's frame 4, 8, and it goes up perfectly. Fantastic. But then finally, let's just say we don't want the first one to emit on frame 0. Say we want it to start on 10 and then go up in those 4-frame increments. Well, to do that, all we have to do is select them all and we can just go num times 4 plus 10. Okay, hit enter, and now we have got frame 10's the start, and then it goes up incrementally 14, 18, 22, 26, 30. Perfect. Excellent. So now we've got this nice staggered emission of our first fluid. That's looking good. Now we need to make our second fluid. So to do that, what we will do is, look, let's copy an emitter. Let's copy the first one. Hold Control, drag it up out of our folder. And this one will go to display. This is going to be our pink particles. Let's change the particle color to pink and the icon color to pink. And we can change the name as well, can't we? So let's change that to emitter pink. And let's make a folder for it. So let's go to our emitters null at the top. And we'll go to Object, Create Folder. Our blue one is still in there from when we made the previous one. Let's change that to pink, Create Subfolder. There it is. Drag this in. Great. And now we can move that one into the hole and then hold Control and let's make some copies. Okay. There we go. So these are all emitting on the same frame. So let's do a similar thing. Let's go to our emission tab and the shot time. We're going to put num times 4 plus, let's make it slightly offset. So the other one was plus 10 to start on frame 10. Let's have this start on frame 12. Okay. And now we should have a really nice staggered explosion of these different coloured emitters. Great. So it's not quite looking like it does in our final render, does it? We're getting a nice initial explosion, but then we're not really getting coloured blobs forming in here. They're all just kind of melding in together with each other and not looking particularly interesting. So what do we need to do to fix that? Well, this is what we need to do. At the moment, all of these fluid particles have the same density values. But what we're able to do is, with all of the pink ones, is to give them a different density value. And this will mean that they will kind of stay together. So let me just demonstrate. In fact, to demonstrate this technique, what I'm going to do, let's just do a new file and let's bring in a cube. And this cube, I'm going to make editable. Let's go to polygon mode, highlight the top and delete it. So now we have a cube with a hole in the top, right? And I'm going to just, in fact, we could probably just make this invisible. Let's take it. I'm going to hit T for scale to broaden it out a little bit. Let's bring in an X-Particles emitter. I'm going to bring that up. And the emitter, we're going to have it pointing on the -y, so it's pointing downwards like this. Okay, and I'm going to copy that emitter, so we've got 2 emitters. The cube, let's give it an X-Particles collider tag, set to be on the inside the collision, and now we can make that cube invisible. So now if I hit play, we've got these particles and they're falling down into the cube. Let's bring in an X-Particles gravity object, and let's bring in an XpOpenVDB FluidFX. So now these are behaving in a fluid-like way. Let's take those emitters, and one of them, let's make it we'll do the same colours as our simulation. One blue, let's do one pink, and we'll change the display mode of both of those to squares so we can see them a bit better. So now, FluidFX is doing its thing, and you can see that they're just kind of gradually bleeding into each other, these different coloured particles, and there's not much mixing going on. But look what happens. If I take the emitter 1 blue particles and go to the extended data tab to the fluid data, and if I reduce the density of this to say 200 from the default 1000, now the blue particles have far less density than the pink ones. And watch what happens in our simulation. The blue particles start floating on top of the pink because they are less dense. So that's really interesting. And we can mess around with these density values. Look, if I put the density way up to 3000, then the blue ones are going to be the ones that will inhabit the bottom of the volume, and the pink ones start floating on the top. So we're able to mix fluids realistically, giving them different density values, and that works really nicely. And this is the trick that we're going to do in our scene. So what we can do with all of the pink ones, let's reduce that density value down to say 200, and let's just hit play, and now you'll see, look, they suddenly start forming into blobs. And we're getting this, and then we're getting the bounce, and that's perfect. That's working absolutely fantastically. So this is the look that we're after. Now, arguably, it would be nice to have a few more pink particles in this bottom area. But all we need to do to sort that out is, let's just take this emitter. Let's control, not all of them, this individual one, control click it over, and we want to give this one a much later emission time. Let's give this one an emission time of, say, 30. Okay, so now we're going to have more pink particles down in this area, and then we've got a few more blobs. We've managed to fill it in, and look at this nice swirling we're getting. So just finally, let's have a look in the collision tag. We had 1% friction in there. Let's just get rid of that, which will help them slide a little bit more, the ones that are touching that surface, and that's looking really nice. Okay, so that's our basic setup. Now, obviously, for different looks, you can change the emission times of both the pink and the blue emitters. You could also include some X-Particles modifiers here as well, for turbulence, for example, to try and exaggerate some swirling. But for me, I'm happy with the initial kind of velocity that the initial explosion is giving us, and this really nice mix of these particles. That's going to do us for our purposes. So you could just leave this as it is and render both sets of particles with different colours. But what we are going to do is take one of these colours and we're going to mesh them with the OpenVDB mesher to give each different fluid a different look. So just to get set up ready for that meshing, let's cache these emitters. Look, we've got lots of emitters in here, and it's going to be much more efficient to cache those first, which means that the xParticles isn't going to have to do the FluidFX solve every frame whilst we're playing around with the meshing settings. So let's get them cached up. It would be a sensible time to do it. So we'll go to other objects. Let's go to xParticles cache, and we'll cache to external files. Let's bring up our file browser again, and we've got our libraries. It's in my MoGraph folder. So remember, we made our fill file folder, and we already set up a cache folder. So let's hit OK. And it's going to cache all of our emitters. So let's hit, in fact, just before we do hit start, let's just increase the frames on the timeline. So we're going to put, let's just put 250 frames, 200 is fine, that's plenty. 200 frames, and let's just hit play. And make sure that we have enough lifespan on our particles. Yep, so that's running right through to the end. Great, so if we go to the cache tag, and we'll build cache. So this is going to cache 200 frames of our FluidFX simulation, and we've got between 9 or 10 particle emitters. So it's still running pretty quickly, really. It's going to be about a 35-40 second cache in the end. So we'll just stay with it because this is going through pretty quickly. No need to pause. And once this is cached, obviously we can play this back without having to solve for FluidFX every frame, so it'll play back much more quickly, which means we can develop the look of the OpenVDB mesher much more easily and intuitively. Right, so if we hit play, now we've got this nice cached, we can really see this nice kind of movement in our blobby liquids. That's working really well. Okay. So obviously you can mess around with the positioning of your emitters. Yeah, you could even put in, as we said, some modifiers to make it swirl around more, like using a turbulence. But for me, for our demonstration, this is working great, and we can really see this wobbliness of this fluid fill. Actually, now we're looking at it, I'm not too keen on this part of the simulation where we're getting a big long blue area down here, and this is a little bit a kind of a separated pink particles at this point. So let's just make a couple of adjustments. What I will do, let's get our pink emitters, and what we want to do is select this one. I'm just going to move this one slightly closer, and then take this one and move it slightly further up. Let's just switch off that cache. Let's see if that's just giving us a slightly less uniform blob. Yes, that I'm preferring the look of that up here. That's nice. And let's just have a look at this down here. So let's just perhaps take this blue emitter, move it up slightly. Move this pink one down. Let's just see if we can just enforce a little bit more grouping down here. Let's have a look. Yeah, they're bigger blobs now. I'm preferring the look up here. Okay, that's looking good. All right, so as I say, you make as many adjustments as you want, and you can tweak this till your heart's content, till you got exactly the look that you like. But for our purposes, that's looking good. So I've made those changes, so we need to obviously recache. So let's build cache, overwrite, and I'll pause this now and come back to you once it's finished. Okay, so that was a very quick cache again, 37 seconds that one, and now we've got our new animation, which is slightly different. Nice bit of wobbling in there, that's looking good. Right, so now at this point, what we can do is we can start meshing one of these colours of particles. So let's go to the generators, and we'll choose a generator and an OpenVDB mesher, which requires a source. So the cool thing about this is what we can do is we can just drop in one of these whole emitters which contains all of our cached particles. So let's make a decision. Let's go with the pink ones that we're going to mesh. So we'll drop that into the source, and immediately we get an incredibly blobby mesh, which isn't what we want. So remember the rules of this though. We're looking at the voxel size and the point radius to make adjustments to this. So let's just increase the voxel size, and then we'll start bringing down our point radius to a point where we're starting to get some of that shape back. So it looks like we're going to have to go lower on this one. Let's go to a point radius of 2, and now we're seeing something that's looking quite interesting. So if I take away the lines, what you're going to see is you can see kind of these shading areas and these kind of squared off, almost looks like glitching, doesn't it, where the OpenVDB mesher is kind of updating and moving those quad polys every frame. And what this is telling me is that we don't have enough resolution in our mesh at this point. It's far, it almost looks voxelized, doesn't it? So what we can do at this point, let's put this editor way down to 1 of ND for the lines. You can see it's a much finer mesh. I think we can go even finer than that, 0.5. Take away those lines. So now at 0.5, we're starting to see individual the detail of individual particles, which isn't quite what we want. So what we're going to need to do here is then add some smoothing. So let's do that for now. Let's go to filters, and we'll go to use filters, and the default's the median. Let's take that off. I'm going to go with the really smooth Gaussian. And now that's a very smooth blob. I think as we have so much detail, look how fine that is. Let's go back to our general tab and reduce the point radius down further. Let's just try a point radius of 1. So with a point radius of 1, now we're getting a smooth mesh and it's really fine. But look, you can see we've got some of the pink particles. So let's try increasing that point radius, 1.1, till we get to the point where we can hardly see any pink, 1.2. There. So now we've got almost the best of both worlds. We've got this nice animated liquid, relatively smooth, and it's moving around within our blue particles, and we're getting this nice kind of swirling. Okay, that's looking pretty good. So obviously we're not getting perfect playback with this because it's having to work out the OpenVDB mesh per frame. So just to get a proper idea of how this animation is looking, let's cache the mesh, and then we're able to view it properly. So what have we got? We have our cache object. Let's go to the cache object. We can build the cache. Let's continue, because there's no need to recache all of these emitters. They're already cached. So let's hit continue. It's going to cache out that OpenVDB mesh. So I'll pause again and come back when it's finished and tell you how long it took. Okay, so that took a little longer than our particles. Lots of calculations going on for all those polygons, but that was 1 minute and 58 seconds. So now what we could do is let's go to the pink. We can deactivate those pink emitters now. Don't need to see those or simulate or read that cache data because the OpenVDB mesher is cached. So let's hit play, and there we go. So there we have our OpenVDB mesh blobbing around the place. and animating nicely. Okay, so in our scene, this is going to work really nicely. So obviously for production levels of detail, what you are going to need to do, should you want to have much more detail in the mesh and much more detail in the particle section of this, would be to have smaller particles emitted in the first place. So if you would go into your emitters, and instead of our particle radius being 1.5, you may want to put that down to 0.5. As a result, you would need to shoot out loads more particles. So you'd need to multiply the particle count, but that would then give you a much more fine, detailed, small particle fluid simulation, which may be the look that you require. Obviously, simulation and caching times would go up as a result. But for us, for our purposes, this is going to look really nice. And remember, this is going to be seen through our transparent, shrink-wrapped bag material anyway. So that is the end of our mixing particles scene. So let's just go to File, let's save incremental, so we've got that one in the bag, and then we can take this element along with the rest of our number 5 and our number 6 scenes, and we can put them together in the render.